These bars are walls. Pick any two and they trap water, so the farthest two should win, right? Not quite. That tiny left wall wastes the width. The real answer is 49, and we can find it in one clean pass. This is a classic interview problem, and it's the perfect follow-up to 2 pointers. In a few minutes, you'll know the one rule that solves it, why that rule is guaranteed correct, and the Java and Python code behind it. Here's the key idea before any code. Imagine holding a sheet between 2 poles to catch rain. It doesn't matter how tall the taller pole is, water spills over the shorter one. So the amount you can hold is set by the shorter pole, times how far apart they are. That's the whole formula. Area equals the width between 2 walls times the height of the shorter wall. Remember that, the shorter wall runs the show. Let's make it concrete. Each number is the height of a wall and its position is where it stands. Pick walls 0 and 8, they're the farthest apart, width 8. But wall 0 is only height 1, so the water is just a thin sliver. 8 times 1 is 8. Being far apart isn't enough. A short wall wastes all that width. The brute force approach is exactly what it sounds like. Try every pair of walls, compute the water for each, keep the biggest. For 9 walls, that's 36 pairs. Fine here, but 1,000 walls means 500,000 pairs, and it only gets worse. That's O of n squared. So let's throw it out and use the trick that made 2 pointers so fast. Same opening move as before. 1 pointer at the far left, 1 at the far right, the widest container possible. We measure its water and remember it as our best so far. Now here's the one decision that drives everything. We always move the pointer sitting at the shorter wall inward, just that. Move the shorter wall. Let me show you why that's not a guess. It's guaranteed safe. Think about our 2 options. Whichever pointer we move, the walls get closer, so the width always shrinks by 1. Now, if we move the taller wall inward, the water is still capped by that same short wall, but with less width. That can only get worse. Never better, so there's no point. But if we move the shorter wall, we lose that same bit of width, and we finally get a shot at a taller wall, which could more than make up for it. Moving the shorter wall is the only move that can ever improve our answer. Everything else is throwing width away for nothing. Let's run it. Start wide. Area 8. The left wall is shorter, so move left in. Now the walls are 8 and 7, width 7, and that's 49. New best. This time the right wall is shorter, so move right in. Height 3, area 18. Smaller, but that's fine. We already saved 49. Move right again. And again. Watch what happens. As the pointers close in, the width keeps shrinking, and nothing beats those 2 tall walls we found early. The pointers meet, and we stop. Maximum water, 49. 1 pass across the array. No pair check twice. Here's the payoff. Brute force is O of n squared. The pairs explode as the array grows. 2 pointers is O of n. Each pointer only ever moves inward, so together they take at most n steps. At 1,000 walls, that's 500,000 checks versus under 1,000. And we use no extra memory at all, just 2 pointers. Same answer, a completely different class of speed. In Java, left starts at 0, right at the last index, best at 0. While left is before right, the height is the shorter of the 2 walls. That's the min area is width, right minus left, times that height. We update best. Then the decision. If the left wall is shorter, move left up, otherwise move right down. When the pointers meet, we return the best area we ever saw. That's the whole method. Same logic in Python. 2 variables, a while loop, and 1 if-else deciding which pointer moves. The shorter wall always steps inward. No nested loop anywhere. 10 lines, 1 clean pass. 4 traps to avoid. 1. Using the taller wall's height in the area. Water spills over the short side. It's always the min, never the max. 2. Moving the taller wall inward or just always moving left. That throws away width for no possible gain. Move the shorter wall. 3. Don't confuse this with trapping rainwater. That's a different problem that sums up lots of little pools between bars. The formula there is not this one. And 4, the width between 2 walls is right minus left, not plus 1. Plus 1 counts elements, we want the distance. Small slip, wrong answer every time. Let's lock it in. Start with pointers at both ends and best at 0. Each step, the water is the width times the shorter wall. Update your best. Then move the pointer at the shorter wall inward, because that's the only move that can ever help. Stop when the pointers meet and return the best. That's container with most water in one clean loop. You just turned an O of n squared problem into a single clean pass with one rule, move the shorter wall. Next, we take 2 pointers one level deeper with 3 sum, where you fix one number and sweep the rest. If this made it, click subscribe. Code clarity, data structures, explained visually.